Good morning and welcome to day 2 of the Patient Advocacy Summit. We hope you had an opportunity to participate in morning yoga. For those of you early and dedicated yoga practitioners, thank you to Novartis for sponsoring both days of the summit morning yoga. And thank you to Ionis for providing this morning's breakfast. I hope you're all ready now to tackle day 2 and that yesterday's events left you inspired and feeling energized for another full day of events. So to help wake you and your neighbor up, I want to start with some informal polling. So as you all know, our mission at Global Genes is to connect, empower, and inspire the rare disease community. So by round of applause, how many of you are feeling more connected to the rare disease community? That's wonderful. If you did not applaud, and it's not because you were holding coffee in your hand or balancing breakfast, then I encourage you to make it a goal to introduce yourself to someone new at a networking session today, attend a guided networking session if you need a little bit more help getting connected, or just stop by the Global Genes booth and introduce yourself. We'd love to get to know you. How about feeling more educated and empowered to fulfill your goals? Okay. Well, with 14 sessions featuring 37 speakers today alone, choose a session that's new to you so that by the end of this conference, everybody is applauding. And how about feeling more inspired? Well, you're going to hear about our Champions of Hope tonight, and you will definitely be inspired. And I'm pretty sure that after our next speaker, you are going to be feeling both educated, inspired, and learn about connections in the rare disease community. So now let's get started. David Fajgenbaum wears many hats. He is an assistant professor of medicine in the Division of Translational Medicine and Human Genetics at the University of Pennsylvania, an associate director of patient impact at the Penn Orphan Disease Center, the founding director of Castleman Disease Center at Penn, and co-founder and executive director of Castleman Disease Collaborative Network, or CDCN. Dr. Fajgenbaum leads 18 studies, including the first ever R01-funded study of idiopathic multicentric Castleman disease, also known as IMCD. His published work has changed the way IMCD is researched and treated. In addition to all of his accomplishments and roles, Dr. Fajgenbaum is also a rare disease advocate and an IMCD patient himself, who is in his longest remission ever, thanks to a precision treatment that he identified which had never been used before for IMCD. Dr. Fajgenbaum's work has been covered extensively by the media, and he just released his second book, Chasing My Cure, A Doctor's Race to Turn Hope into Action. His book is an inspirational memoir of a rare disease patient turned clinician looking for a cure. He's also one of the nicest people I have ever met. So please join me in welcoming to the stage Dr. David Fajgenbaum.
Wow, thank you so much for that introduction, and it is just such an honor to be here with all of you guys today. I can remember so well being here back in 2015 at my first Global Genes Summit, and just being so excited to connect with, to learn from, and to see heroes that I had heard about, like Nicole Boyce and Kyle, people who I looked up to so much, and to be able to get the chance to be here with all of you today and to speak to all of you means so much. I titled my talk Personalized Medicine because I conduct research and I perform personalized medicine on the same disease that I'm also personally battling as a patient. This is a picture of me as a healthy third-year medical student at the University of Pennsylvania, where I was training to become an oncologist to treat cancer patients in memory of my mom, who had passed away just a few years before. And this is a picture of me just a month later, where I was dying in the intensive care unit at the same hospital that I'd been treating patients. I had liver failure, kidney failure, my bone marrow had shut down, I had a retinal hemorrhage and went blind in my left eye, I gained 70 pounds of fluid, and I was so sick that the doctors encouraged my family to say their goodbyes. Around that time, my family had a priest come in and administer my last rites read to me. So ever since November of 2010, when I had my last rites read to me, I've considered that to be the start of my overtime. And overtime, of course, being extra time that I didn't think that I would have, but time where every second counts and where I have to make the most of every single second. So today I'm going to share a bit more about my personal story, my journey with Castleman disease. I'm going to share some of the challenges that I faced when I first got involved in the Castleman space, challenges that many of you all are facing, share some of the solutions that we've come up with for Castleman disease, and try to close with some future directions and lessons learned that I hope all of you can take back to your particular rare disease. So if having my last rites read to me in November of 2010 was the start of my overtime, I like to think back to what was my first half and what was the second half of my life. Well, the first half of my life was growing up in Raleigh, North Carolina with a dream of playing college football. That's all I wanted to do, and that's really all I was focused on. And I had the opportunity to go to Georgetown and to achieve this dream of playing college football. And about 2 weeks after I got to Georgetown, I had the most challenging and difficult experience of my life, and that was when my mom was diagnosed with a terminal brain tumor, with brain cancer. And I learned that she had this deadly illness and that she would most certainly die within a short period of time. And so, though football had been my calling and my life for the first half, immediately my focus changed towards wanting to become a clinical oncologist, wanting to treat cancer patients like my mom. This is a picture of my mom and I just a couple months after her brain surgery. And her battle with cancer, the way that she faced brain cancer, was the ultimate example of how to fight with force, but also to live and to die with grace. And watching her was just so inspirational, while at the same time so devastating for me. Just before she passed away in October of 2004, I promised her that I would create something in her memory for grieving college students. I didn't know what it would be, but I told her I would call it AMF. Her initials were Anne-Marie Fajgenbaum. And so we decided to create this group, Students of AMF, after her passing, for grieving college students to support grievers during such difficult times. My mom's passing inspired me to continue to pursue this goal of becoming an oncologist, to treat patients like her, while also continuing to grow this network, AMF, around the country. We were able to raise a lot of awareness, and actually my face was in the back of 40 million bags of Doritos back in 2008. We raised a lot of awareness through media, through the Today Show, and a number of other outlets for this issue of grief during college. How do you support people that are dealing with illness and death at such a young age? I was able to finish up undergrad at Georgetown and go to England for grad school, and then I was a couple years into medical school at the University of Pennsylvania. This is another picture from July of 2010. Healthy, no medical issues, training to be an oncologist in memory of my mom. And then this is that same picture that I showed you earlier of me dying in the intensive care unit with multi-organ failure. Over the course of the next 3 months, I would continue to not have a diagnosis. It was about 11 weeks total with no diagnosis, but eventually a lymph node biopsy was performed and the diagnosis of Castleman disease was made. This is a picture of that lymph node. I'm not going to go into the details of it, but there's, in particular, it's the vascularity of the lymph node that led the pathologist to think that this, in fact, was Castleman disease. And so finally, I had a diagnosis, idiopathic multicentric Castleman disease. Like many of you with rare diseases or with a family member with a rare disease, you'd probably never heard of that rare disease before you were diagnosed. And though I was a third-year medical student, I actually had not even heard of idiopathic multicentric Castleman disease before I was diagnosed. Right around the time that I had my last rites read to me, that was when the diagnosis was made, and so I was able to be started on multi-agent chemotherapy right away. I got a combination of adriamycin, Cytoxan, etoposide, Velcade, dexamethasone, thalidomide, rituximab, 7 really, really intense chemotherapies with the intention of trying to obliterate my immune system. Castleman disease is kind of like a cross between an autoimmune disease and a cancer. The immune system gets out of control and attacks your body's vital organs, but we don't know how and we don't know why. And so chemotherapy is one solution where you just kill the immune system. And it worked for me. And you can see here I'm sitting up and feeling well. I'm with my dad, and I'm just so happy to be alive. Right around this time, was when I was starting to feel well enough to go for walks with my dad around the hematology-oncology floor. And this picture is actually from New Year's Eve of 2010. My dad and I decided to go for a walk that evening, and you can see due to my liver failure and kidney failure that I have a pretty big belly, and I'd gained a lot of fluid all over my body. And from that, on that evening, my dad and I went for a walk, and as we passed by the family waiting area, we noticed there was a gentleman who looked like he'd been drinking on New Year's Eve. He was kind of swaying in his chair. And then we did another lap around the floor, and we saw that this guy had fallen onto the floor. And so my dad ran over to him and helped him back up into his chair. And he looked at us, he said, "Thanks so much, good luck to you and your wife." My dad and I said, "Wife? What's he talking about?" Then I looked at my belly and I realized he thought I was my dad's pregnant wife, which was a low point emotionally for both of us. But I turned to my dad and I said, "Man, you've got an ugly wife." But we managed to laugh in the midst of a really tough time, which I think is something that all of us in the rare disease community have tried to do and have found to be so helpful during some really, really tough times. So over the course of about 6 months, I spent about 5 months of that time hospitalized, most of that time in critical condition. But thankfully, and with chemotherapy, I was able to leave the hospital after about 5 months. And this is a picture of me after I got out of the hospital. And you can maybe see how someone maybe thought I was a pregnant woman from this picture. And then this is a picture from a couple years before when I played college football. And I always say this is like the worst before and after picture of all time. But if we could flip the order, it could be an advertisement for like Shake Weight or Muscle Milk. Unfortunately, it's in the wrong order. So I took a picture for the next, every week for the next 8 weeks, and you can see the fluid beginning to go away, and you can see my hair starting to grow back after the chemotherapy. And really, thanks to the chemotherapy, my life was saved. At this time, I was started on an experimental drug, the only drug to ever undergo a randomized controlled trial for idiopathic multicentric Castleman disease. And I was really hopeful and optimistic that this drug was going to keep me in remission. I could return to medical school, get back on my track to treat cancer patients in memory of my mom. And so after about a year of medical leave, I did return back to Penn for medical school. Oh, I took pictures from the side as well. These are pictures from the side. So I was able to return back to Penn for medical school, and though I had this rare orphan disease, I knew there were people in France and in Japan and across the US that were studying Castleman disease. I didn't know what they were doing exactly, but I just kind of believed and hoped that the people out there doing Castleman's research were going to make the progress needed for me and for other patients with my disease. And so I went back to medical school, got back on the previous track, and the only Castleman's research I did is I wrote a case report about myself. And so this is I was the first author of the case report. I was also the patient. And the reason I wrote this case report is that when I was in the ICU, I would only be awake and conscious for about an hour a day. But the only thing I could think about, I was fixated on these blood moles that were appearing on my chest and shoulders. This is a picture of one of these blood moles. And there I was dying in the ICU, and every time the doctors would come and I'd say, what about the blood moles? And they kept saying, your liver, your kidneys, your heart, your lungs are all failing. Forget about the blood moles. They don't mean anything. But on subsequent relapses, what I found is that these blood moles have erupted. They've grown right before I relapsed, and they shrink away with treatment. So they really did mean something. So I wanted to get that out to the community. So though I wasn't interested in Castleman disease research, I did want to get involved in the Penn Orphan Disease Center. A major gift had been given to Penn to start this orphan disease center. And I went to the founding director, and I said, I have an orphan disease. I'm on an orphan drug. I want to be a part of the Penn Orphan Disease Center, and he graciously allowed me to be a part of ODC, and it's been such a pleasure to be a part of ever since. A little bit about Castleman disease. There's about 5,000 patients diagnosed each year in the US, which makes it about as common as ALS, certainly much less well known. There are 3 subtypes of Castleman disease. My subtype, what's called idiopathic multicentric Castleman disease, is the most deadly and poorly understood. Of course, anything with the word idiopathic at the beginning means that the cause is not known, and it's typically poorly understood. It really affects your whole body, and that's because your immune system gets out of control and then attacks all of your vital organs. It sits kind of at the intersection of autoimmunity and cancer. We actually don't know whether to consider it a lymphoma or an autoimmune disease because it shares features of both. About a third of us will die within 5 years of diagnosis, and another third will die within 10 years of diagnosis. Importantly, this disease affects individuals of all ages. So our youngest patient is less than 1 year old, and our oldest diagnosis is over 70. At the time, back in 2010, when I was diagnosed, there was one drug in development. And really the reason that there were so few treatment options is because the disease was so poorly understood. So I went back to medical school. I was able to get involved in ODC, and then I had a full-blown relapse. This time it was caught a lot earlier than previously. You can see I'm vertical at the time, but my organ dysfunction was clear, and the blood work showed that I was having my 4th episode. And so for the 4th time, I got extremely ill. Fortunately, I survived, but right after this picture was taken, I had a really important conversation with my doctor. He's the world's expert for Castleman disease, and as a rare disease patient like many of you, I felt like what I needed to do was get to the expert. If I could get to the expert could tell me what I needed to know and get me the treatment that I needed. And there I was with the world's expert, and I said, okay, Dr. Van Ree, I've relapsed on the only drug in development, or I'm relapsed on this drug, what else is in development? And he said, well, there are no more drugs in development. I said, okay, well, what other leads are there? There must be cell types or signaling pathways. I know people are doing work. There must be some other lead, right? He said, no, there are no other leads. I said, well, there must be some promising researchers out there that are doing work that have something that I should be hopeful about. And he said, no, there isn't. And so within minutes, I went from being this optimistic, hopeful medical student who believed that the medical community is solving problems that we can't even see. They're in the background fixing diseases and solving things, to realizing that actually for many diseases, like many of the diseases you guys are facing, there aren't these workshops of people working behind the scenes that are solving diseases. And unfortunately, if I wanted to live, if I wanted to turn my hope for a future, a hope with my girlfriend at the time, now wife, that I needed to turn my hope into action, that I could no longer just hope and pray that someone somewhere in France or Japan or somewhere in the US would figure out my disease, that if I really wanted to have a future, that I would need to turn my hope into action and get involved in research. And so I promised my dad, my sisters, and my wife that day that I would dedicate the rest of my life, however long that may be, to trying to identify treatments and cures for this disease. Over the course of the next couple weeks, I improved, and actually this is the day before I was discharged from the hospital. They let me leave the hospital with my wife, and you can see on one of my shoulders is my chemotherapy. I'm getting the 7 agents infused in me, and then on my other shoulder is my wife who's providing me support, and I think this is very symbolic of the support that she's provided me over the years. This is from a few weeks later, and I think you can appreciate, of course, my hair's fallen out at this stage, but you can appreciate that I'm like laser focused at this stage, locked in. What can I do to identify a treatment or a cure for Castleman disease? And I was also completely overwhelmed. I'm a third-year medical student. What could I possibly do to make a difference? But for me, I realized that though it was unlikely that I would identify a drug that could help me, or it was unlikely that I could truly make a difference for myself, I knew that it was impossible if I didn't try. I knew that there was a 0% chance that any progress could be made if I didn't try, and that there was at least some chance, an unlikely but some chance, that if I turned my hope into action, that I could create something, and I could build something that could actually make a difference, something that all of you know all too well. So I started out by conducting laboratory research at UPenn. There were no researchers studying Castleman disease, but I had a friend who ran a lab and gave me some space in her lab. I started a foundation called the Castleman Disease Collaborative Network to try to bring together patients, physicians, researchers all together to fight back against Castleman disease. And I continue to work in the Orphan Disease Center to try to apply what we learned for Castleman disease to other rare diseases, and what we learned for other rare diseases to Castleman disease. So in this next part, I want to just go through briefly some of the challenges for Castleman disease and other rare diseases that many of you guys will certainly appreciate. So back in 2012, this is when I decided I would take on the disease. I learned really quickly that IMCD was very poorly understood. There was no diagnostic criteria, no treatment guidelines, no biomarkers to predict a response to the one drug in development. But even worse than how poorly understood it was, there was no research infrastructure in place to actually coordinate and push forward the science. So very few people were collaborating. The studies had very small sample sizes. There were no cell lines, animal models, natural history studies, no registries, and no biobanks. There was zero NIH funding for IMCD research, no patient advocacy group focused on research. There were 2 patient advocacy groups, but they were fully focused on supporting patients and on referring patients to experts, but no one actually focused on research. And there were 0 FDA-approved drugs, no drugs in development other than this one that I mentioned earlier. So it was frightening to be in the hospital and to hear how bad things were. I think it was maybe even more frightening to be out of the hospital and hear how poor things looked. So once I saw how bad things were, the next question was, well, how do you move forward research? What's the way that research typically advances? And as many of you guys will be aware, there's a RFP approach generally to research, and that's where you raise money as a foundation, you invite the best researchers to apply for that money, and then you select the very best applicants to give the money to. And that works really, really well when the NIH does it, or when you have hundreds of applicants and millions of dollars. But for a disease like Castleman disease, where you've got a handful of researchers and you've got maybe $5,000 or $10,000 grants to give out, it is extremely unlikely that the best researcher in the world is going to come up with the best idea for what needs to be done and have the right skill set at the right time. I mean, it's just not going to happen. And so this approach, when you have limited resources and when you have a limited number of researchers, is basically like waiting for the stars to align. You're hoping the right researcher applies for the right project at the right time. And when you're a rare disease patient or loved one like all of us are, we don't want to wait for the stars to align. And so we decided we wanted to take a different approach to research that really is patient-centric, patient-driven, but really community prioritized to get away from hoping the right researcher applies at the right time to figuring out what is the right research study and then who is the right researcher so we can get them to do the work right now. So the approach that we took is what we call the collaborative network approach. And that's where basically we went from this approach of raising money and hoping the right researcher applies to saying, let's build a community. Let's get all the patients, the researchers, and physicians together. Let's use that community to prioritize what needs to be done, and then let's go recruit the best people to do that work. So step one was to build a network of about 400 physicians and researchers, and at the time about 1,000 Castleman disease patients from all over the world. Then to use that community to define what is known today, because you can't really decide what you want to do for research tomorrow if you don't have a really good grasp for what is known today. So we utilize the community to determine what do we know about Castleman disease today. Once we did that, we used that same community and that same brain trust to establish the first ever diagnostic criteria and treatment guidelines based on what we know today. What's the best way to diagnose it? Based on what we know today, what's the best way to treat this disease? The next thing we did, once we had a solid understanding for where we are today, then we went back to that same community and we asked 3 simple questions. What are the most important research questions that need to be answered? What are the most important studies that can answer those research questions? And who are the best researchers in the world to do those studies? So to get away from saying, who wants our money, to saying, how should our money be used? And then let's go out and find the best person in the world to do that. So then we started to recruit experts. We had very clear studies that we needed to fundraise for now. We had this prioritized list of about 20 studies, and fundraising became a lot easier because we could say, we want to raise $100,000 for this exact study that's going to be done by this researcher at this institution. The next thing is that we needed samples and data because now we were recruiting people to do Castleman's research that didn't treat Castleman's patients, and they'd never done Castleman's research before. So they didn't have any samples to work with. We were finding the best people in the world for a given type of study, but we would need to give them the samples to actually work on, and so we did that. We would push forward these studies, execute them, and then as soon as we learn anything about the disease, we always try to share that information back to the community so the community can continue to contribute ideas towards research so we can get better and better at pushing forward our science. Another thing that we do is we always try to say, from our research studies, what we're learning, are there certain drugs that maybe target those things that we're finding to be abnormal that already exist, drugs that are already FDA approved for one thing that might be able to be used for Castleman disease tomorrow as opposed to years from now. We also run a natural history registry, and this is really critical because of the way that we do research, we encourage off-label, I don't know if I should use the word encourage. There's a lot of off-label drug use that occurs in Castleman disease. And because there's a lot of off-label drug use that occurs in Castleman disease, we want to track whether that off-label drug use works or not. Because in the rare disease space, you guys will all be very aware, doctors often try drugs that have maybe not been used for that disease before based on some research and they're hopeful it'll work. But unfortunately, those data are almost rarely collected. And so if you don't collect the data, then every time you do one of these experiments where you're giving a patient an off-label drug, you're not learning from it. So you can't build upon that use for the next patient. So we always try to collect that data and assess it through our natural history registry. Based on the data that we collect and drugs that we find in our study that seem to be working, we move forward to launching clinical trials so we can rigorously evaluate, based on what we're seeing in the real world, is it true that there is a real signal here, with the ultimate goal of personalizing medicine, so we can say that we can identify the right drug for the right patient right now. In parallel to this approach, we also track all of our research studies on our research pipeline in one central place. Any researcher, any patient in the world can go to one place and they can learn everything they need to know about all of the research that's being done all over the world for Castleman disease. This is really critical for when we go to recruit new researchers, they can know what's the landscape look like. Who is doing what, so I can know where my areas of opportunities are. And it's also great for patients to know how are we using their money. In parallel, we're constantly collecting samples and data, so that way we can share it with our researchers. We connect and support patients all over the world. And something I'm really, really proud of is that the work that we've done through this collaborative network approach is really on the shoulders of amazing volunteers, people like Wes, who's here, friends, people in the Philadelphia area that have just gotten behind the Castleman disease fight, put their time, their energy, their effort into Castleman disease, whether they're friends or patients, medical students, just getting behind the CDCN approach. And it's thanks to this incredible army that we've made so much progress. So I'm not going to go through all of our studies on our international research agenda, but I just want to highlight the way that we try to organize our studies. So after we crowdsourced and identified what needed to be done, we went out and figured out who's the right person to do it. We have in this one central place a listing of all of our studies that are in process or that at least have been started since we prioritized these studies. So back in 2010, when we started this journey, none of these studies were going on, but thanks to this really incredible work from this army that we have, we've been able to launch a number of studies and publish a number of studies thanks to this hard work. Over the last 7 years, we've raised and invested about $1 million into research. That's cumulatively over 7 years. Many of you guys will appreciate that that may seem like a lot, at least it seems like a lot to me from when we came from the beginning, but to others it may seem like not very much. But that $1 million that we've put into research has resulted in an additional $7 million in funding from industry and from the federal government that are actually infusing money into the Castleman space because of the $1 million and because of the data that we generated from the $1 million that we put in up front. That work and the money we've invested has resulted in the first novel drug target in 25 years, the first diagnostic criteria, the first treatment guidelines, and also the first clinical trial ever of a drug for these treatment refractory patients, really the most critically ill and severe patients. So we've been able to make a lot of progress with a limited amount of funding. But that's today. That's where we are today in 2019. Back in 2013, when I finished medical school, we had just started on this journey. We were a year into this fight against Castleman disease. I had a year worth of data, a year of data from my samples in the lab, but really very little progress had been made at this stage. This picture is from my medical school graduation with my wife, Caitlin. At the time, we just gotten engaged. And we were so hopeful that I would make it, excuse me, to May of 2014. We were set to be married in May, and of course I have this awful terminal illness, and so I couldn't really think beyond May of 2014, but I just wanted to make it to May 2014 so bad. I just wanted to make it to our wedding day. And unfortunately, just a few months after graduating from medical school, I had another deadly relapse. This was the fifth time that I approached death, and there are no pictures from that time, in part because it was just such a scary time for all of us. I said goodbye to my family, said goodbye to Caitlin, and thankfully, I was able to survive thanks to chemotherapy. But at this stage, for the fifth time I'd almost died. For the fifth time, chemotherapy saved my life, but I was getting closer and closer to the lifetime max of chemotherapy that any human can take on. I'm still very close to that max, but getting closer and closer to it. So we were basically running out of time. Every time you have one of these IMCD flares, about a quarter to a third of us will not survive one of these flares. At this stage, I now had it 5 times. So it's like playing Russian roulette 5 times. And so really, really running out of time, and I needed to dive into the data that I had, needed to dive into the samples that I had to try to figure out something. Is there some drug already FDA approved that I could take that could prevent this from coming back, again, just so I could make it to May of 2014. Just to give you kind of a sense for the scientific problem that we had here is that in Castleman disease, we know the entire immune system becomes activated and attacks your vital organs, but we don't know what it is that initiates that immune activation. This is just a simple cartoon to represent different cell types, but actually there are hundreds of different immune cell types, and there are billions of immune cells distributed all throughout your body. So we didn't know what cell type it was that initiates it. Within every one of those cells, there are hundreds of different pathways. There are thousands of genes and thousands of proteins that are all interacting and work together, and we didn't know which one of those hundreds of pathways was involved. And each one of those cells secretes hundreds, if not thousands, of secreted proteins that all contribute to what we call idiopathic multicentric Castleman disease. So hundreds of different cell types, hundreds of different pathways, thousands of secreted molecules, and we need to figure out which one of those is the thing to go after with a drug, or maybe a couple at the same time. So a really challenging problem that we faced. But as I dug into my data, and I've been running experiments on my samples every month leading up to my last relapse, I found that there were two proteins. One's called VEGF, vascular endothelial growth factor. Another one's called soluble IL-2 receptor that's produced by activated T cells. There were two of the earliest proteins to rise. So as we measured it month to month leading up to the flare, we found that these two things rose early. I also had blood samples stored from previous relapses, and so I ran some additional experiments called flow cytometry and also immunohistochemistry, and I confirmed that, in fact, there were activated T cells in my samples in the time leading up to flare. So I thought maybe VEGF and these activated T cells, maybe we could use a drug against one of those two targets. Well, fortunately, there is a drug that targets VEGF called bevacizumab. There's also a drug that targets T cells called antithymoglobulin. Both of them are chemotherapies, and both of them have really, really bad side effects. And our question was, well, what if we target one, but it's really the other one? Could we combine them? They've never been combined before. So our questions then went to, is there something that links T cell activation and VEGF? Is there kind of a final common pathway that's involved in both VEGF production and T cell activation? And there is. It's called the PI3 kinase AKT-mTOR signaling pathway. And we went back to my proteomics data, and we found that actually within my proteomics data, there was a signal from this pathway, this PI3 kinase AKT-mTOR signaling pathway, with what you call enriched. There were more proteins in my blood from that pathway than you would expect by random chance. And so now we had a potential common pathway that links the VEGF, the T cell activation, and we asked the question, is the mTOR pathway actually activated in my samples? And I think this is my only slide with specific research data showing this, but I wanted to show you quickly, basically we did a study called immunohistochemistry. It's where you look for mTOR activation, and brown stains, or positive staining is brown, cells, nuclei stain blue, and so you can see here, this is a normal lymph node. You can see that it's mostly blue because it's mostly normal cells with a little bit of brown, so a little bit of mTOR activation in a normal lymph node. And then this is my lymph node, and you can immediately appreciate that there's a tremendous amount of mTOR activation. And so at this stage, we found VEGF, T cells, we found a final common pathway, something that could be involved in both VEGF and T cell activation. And fortunately, there's a drug that targets mTOR. It's called sirolimus. It was developed 25 years ago for kidney transplantation. It had never been used before for my disease, but we now had a reason to try it. We thought maybe this drug could be helpful for me. And just because mTOR was up doesn't mean that blocking it's necessarily going to work, but it's all we had. It was the only lead that we had at this time. So I started on this drug 5.5 years ago. It's now been 68.49 months since my last relapse while I've been on sirolimus. Thank you. And I say 68.49 months because I know I can't round up. I don't know if this drug's going to, or if this disease is going to come back in 2 weeks or 2 days. I know that it's explosive and can come out of nowhere, so I know I can't round up. But I also won't round down because my team and I, we worked really hard for those 0.49 months. The New York Times called this "Doctor Cure Thyself" when they wrote an article a couple years ago, which I think is a bit of an overstatement. I think it should be doctor helping himself a little bit right now, and hopefully for a long time longer. But I don't think that would have fit as the headline. But fortunately, in this time, my wife and I, we were able to get married. This is from us on our wedding day, May of 2014. And actually, you can see that my hair grew back just in time. So that's never been cut. That hair had never been cut before. It looks like I'd maybe gotten a buzz cut. It was brand new hair. And maybe that doesn't seem like a big deal, but I really, on my wedding day, Castleman's is below the surface. I didn't really want my Castleman disease and the fact that I just had chemotherapy on the surface for Caitlin. And amazingly, a year ago, my wife and I were able to have a daughter, Amelia. This is my sweet girl who is just the best gift and something and someone that I never thought that I would be able to have. I remember when I was dying in the intensive care unit the first time, mourning the fact that I would never be able to get married to Caitlin and that we would never be able to have a family together. And now to be here and to have my sweet Amelia is something that I just didn't think ever would be possible. Thank you. Thank you, Mike. This is a picture of a patient who came to the Children's Hospital of Philadelphia about a year ago. He did not respond to either first-line or second-line therapy in Castleman disease like me, and he was really, really sick. We ended up giving him sirolimus, and he had a really, really positive response. Joey's back to playing soccer again and feeling really well, thanks to a drug that no one had ever thought to try in Castleman disease. We've now given the drug to about 10 other patients. It's worked in about half of them. Unfortunately, it hasn't worked for everyone. In fact, it's the most sick patients that the drug has not worked in. Fortunately, it did work for Joey. This is another one of our young patients, Katie, who has a different subtype of Castleman disease, but had a really tough road with multiple years of being on oral chemotherapy daily, and she's been transitioned to sirolimus and has actually responded quite well. So we're super excited about the progress we've made thus far with this drug. We just launched a clinical trial 2 weeks ago at the University of Pennsylvania. Looks like we're going to enroll our first patient today, actually. I just got the email and call this morning. Yes. But we know that there's still a lot of hard work ahead of us. We know this drug isn't going to be the solution for everyone, and so we continue to push forward the science as quickly as we can. So just to kind of summarize where we are today, we know more about the disease. We've uncovered some new mechanisms. We have diagnostic criteria. We have treatment guidelines. We have 18 studies that are currently in process. We've got a huge network of physicians and patients all working together. We have a natural history registry. We have a biobank. We did get the first federal grant for IMCD this past year, which includes funding for this trial that I mentioned. We've got patients engaged in all aspects of what we do. And excitingly, siltuximab, the drug that didn't work for me, ended up getting FDA approved. It works for about a third of patients, and so that's huge for our community. There's an FDA approved drug that works for a third. We're now working on drugs for the other 2/3 of us and continue to push forward the science as quickly as we can. So in the last about 10 minutes of my talk, I want to share some future directions and some lessons that I hope will be helpful for all of you. I remember when I was here in 2015, I was frantically writing down everything that I could to try to learn as much as I could from the speaker, and so hopefully this will be helpful for you guys. There's 2 cartoons that I have on the screen that I think are important here. The first is that I have this brand new idea about a wheel, and the idea is that we shouldn't be reinventing the wheel, and that we should share all of our ideas because it may be that what seems like a breakthrough for one person may actually be really critical for someone else. And we all are part of the rare disease community. Rare is one. We need to all work together and share with one another. The other is this old dog who's reading about new tricks and thinking about a drug like sirolimus, been around for a really long time. But sometimes these old drugs that have been around for a long time can actually do new things that we never thought were possible. So for me and the work that we're doing, we are focused really on three paths forward. The first is continue to advance drug discovery for Castleman disease through the Castleman Disease Collaborative Network, this global nonprofit, and also the center that I run at Penn called the CSTL, or the Castle. And thus far, we know that the one drug I mentioned works for about a third of patients. We've kind of, gotten a bit of Castleman disease under control. And we know this drug that we're now studying in clinical trials, we're hoping that it's going to take care of, another part of the Castleman. Maybe another third of patients will get better. But we're going to continue to stay focused on figuring out how do we knock this disease out? How do we take out Castleman disease completely? But we also are starting to expand beyond Castleman disease. So thinking about diseases that are related to and intersect with Castleman disease, diseases like autoimmune conditions, rare and inflammatory disorders, where there are things we can learn about Castleman disease for those diseases and vice versa, and always focusing on trying to repurpose drugs. And then lastly, trying to spread the collaborative network approach beyond Castleman disease and even beyond related inflammatory disorders. And that's in partnership with the Chan Zuckerberg Initiative. They've been an incredible partner to the whole rare disease community, joining the fight over a year ago, and in particular with our foundation, trying to think about ways that we can expand this collaborative network approach to other rare diseases. So trying to visualize here that there's 7,000 rare diseases, including Castleman disease, Castleman disease being one of those 7,000 diseases. But we think about this really in a at least three-step process, but there's even sub-steps to that. The first is really to try to get rare diseases to see if there are ways to implement this sort of collaborative network approach to bring together stakeholders. Secondly, to utilize the data from the collaborative network approach to look for drugs that are already FDA approved for something that might actually be able to be repurposed for your disease, so you can use that drug tomorrow instead of 20 years from now. With the hope being, as of right now there are 1,500 drugs that are FDA approved for at least one condition, and a total of about 2,500 diseases have an FDA approved drug, but there are over 7,000 diseases, almost all rare diseases, but over 7,000 rare diseases that don't have any FDA approved drugs. So, can we start to study off-label drug use and see if maybe we can start getting a larger portion of diseases covered with existing agents, as opposed to having to always develop new drugs? And new drug development is critical, and we need new drugs, but can we look in our rearview mirror and see what drugs already exist that could be helpful? So we just recently wrote up a description of the collaborative network approach. I hope you guys could all find that useful. I'm happy to share it with anyone and everyone, but really we break it down into 8 pretty simple steps. So first, build a community. Use that community to identify the right research. Then identify the right researchers to do the studies that you've prioritized. Fundraise specifically for those studies that you've now identified a researcher for and prioritized. Do sample procurement and data procurement, because if you're bringing in researchers from outside of your fields, they're not going to have samples and data. You're going to need to provide those to those researchers. Next, performing the studies, and I think sometimes we as foundations can sometimes think that the researchers can just do their thing on their own. We give them the money, we give them the samples, and they do their work. But actually, I can tell you, we researchers actually really love to work with you guys throughout the process. That's really important to us, and so I really encourage you to be a part of study execution as well. The next step is this data analysis, looking for potential off-label drug use. Anytime we get any data back in any of our studies about a pathway, a cell type, a protein, there are a number of databases, I'll mention a couple in a few slides, that you can go to see, is there a drug that's already approved that targets that particular pathway? And then critically and importantly is disseminating knowledge. And this is really a cycle, because as you're sharing about what you learned from initial studies, hopefully that'll help to feed back on future studies. For us, building a community is getting together all the physicians, researchers, and patients worldwide, capturing that information in a secure database, and connecting the community. You can see there's a few CZI collaborations that I highlight where we're specifically working with CZI to retool and improve some of the tools that we've used over the years that have helped us for Castleman disease, and hopefully those are tools that can help other rare disease groups. We've joined together a large network of physicians and researchers. You can see we've got some physicians here doing what we call our Castleman Flex, and then again a bunch of patients here doing this Castleman Warrior Flex. So I've talked a lot about research today, a little bit about patient engagement. So I don't know if this immediately comes to mind, but this is a Castleman. I don't know if you guys thought that when you saw this. When we first started the CDCN, we held a webinar for patients, and I showed it to patients and said, what do you think about this being our logo for the CDCN? And they kind of laughed the way you guys did, and it was like, I don't know about that, Dave. He's kind of puny, and I don't know if he really represents the warrior that we've been fighting. And so we went back to the drawing board and we made a new Castleman. And so we held another webinar and shared it with our patients. And then 2 weeks later, this showed up on our Facebook page. And so one of our patients had gotten it tattooed on his shoulder. And I always say, if this is not patient engagement, then I don't know what patient engagement is. But we've got a lot of Castleman's patients that have the warrior tattooed on their shoulders and I think, and all over their bodies. I think that this is just representative of the fact that our community was just waiting for something to get behind. We so badly wanted to get behind and fight as part of a team and as part of an army. I know that's something all of you guys can appreciate. These are some of our Castleman's patients. As I mentioned, affects individuals of all ages and is really relentless when it gets started. And unfortunately, chemotherapy until now has been one of the few things that's helped. And a number of these patients are no longer with us. And so we think about these patients. I think about them all the time. And even despite the progress, we still lose patients all the time. And that breaks our heart, but it also pushes us to keep working harder and harder. The next step, crowdsourcing, is directly asking what questions are important to you as patients, what questions are important to you as physicians and researchers. I'm trying to understand what are the things that we can do so that we can help save more and more patient lives. And of course, I mentioned earlier tracking these in a central place. We've tried to get our research framework to move from just being a very simple framework like it is here, that this cytokine is causing Castleman disease, to getting to a much more in-depth framework so we can really start to tease apart biology. I think this is really important for every rare disease to work with your scientific advisory board to say, I want you to draw a simple cartoon that all of us can understand and be on the same page. And if your scientific advisory board can't do that and can't say this leads to this, leads to this, you need to really work with them because it's really important to have kind of a ground truth that we're all working off of and a map. And so I really encourage you guys to work with your SABs to do that. Going out and identifying top researchers is a fairly straightforward process. Again, all of this is described in the paper. Fundraising, we don't do anything magical. We do the same online fundraising, the same events, and individual donations that all of you guys do. And probably that you guys do much better than us. We also, sample procurement. One thing that we do that is a little different is we do direct-to-patient enrollment. So we enroll patients, and we can send patients directly either online or by telephone. So if patients might be in a hospital in California, and we'll consent them by email or by phone from Philadelphia, we'll get samples shipped overnight and take care of all logistics. We found that working with physicians is really important, but if we can work directly with patients, it oftentimes is a little bit easier. Our natural history registry also enables direct-to-patient enrollment. We work with Pulse InfoFrame to be able to get patients to consent themselves online, get into the registry, and get data entered on all those patients. For study execution, again, I think the key is just knowing as a foundation that you can be a part of and you should be a part of following the progress of studies. Putting in milestone payments so that you don't give all the money up front, you give payments or you make payments with particular milestones that the researchers achieve. I think these are all really important and reasonable asks that you guys should have. Data analysis, I'm just going to mention a couple of tools that we like to use. One's a website called Enricher, and Enricher is free and openly available to anyone. It's where you can enter in proteomic, genomic, transcriptomic data, and you can get an idea for some pathways that are enriched. Pathways that maybe could be drugged. There's another database called Links 1000, which you can actually find also in Enricher, which will tell you about the genes that are actually either upregulated or downregulated by particular drugs. Again, this is sharing it with your community. Anyone can use it. And then the last is a database of approved and also not yet approved drugs, a website called Open Targets or targetvalidation.org, where you can see what are the drugs that are already out there. And then, of course, knowledge dissemination, just getting this out to the community. So I'm going to close with a couple slides talking about chasing my cure. So I recently wrote a book called Chasing My Cure. It came out last Tuesday, and it really chronicles this journey from being a medical student through nearly dying 5 times and eventually identifying a drug that's keeping me alive. But the reason I wrote this book, really 2 main reasons. One is that I learned a lot about life and about living from nearly dying 5 times, lessons that many of you all actually already know because you've been facing such similar challenges, but lessons that not all of us know, and unfortunately sometimes it takes going through these sort of challenging journeys to learn these lessons. I also wrote this book to raise awareness about the challenges in the rare disease space and what we're all going through, and about how more research needs to be invested into rare disease research, about how off-label drug use could potentially provide solutions for a lot of us in the rare disease space. So the first lesson that I want to highlight is that we need to work together within and across rare diseases. The book's titled Chasing My Cure, but really it's chasing our cures, because as we push forward the science for any one of our cures or any one of our diseases, these are potentially drugs and solutions that could actually help many of us. Another is that we really need to establish what's known today before you can start pushing forward your science for tomorrow. I think this collaborative network approach that we describe in the paper and that we're trying to retool with Chan Zuckerberg as the collaborative network approach 2.0 is something that could help many rare diseases, and I hope it's helpful for you guys. Importantly, there are a lot of new tools that exist that need to be leveraged to identify cells, signaling pathways, proteins that could be targeted with existing drugs. Let's not just think about new drug development, although we should definitely be thinking about new drug development. Let's also utilize the tools that exist to see what drugs already exist that may be able to help us. And if you do off-label drug use within your community, make sure to systematically track off-label drug use so that way you can learn from every time that those drugs are used. I mentioned earlier that I've considered myself in overtime ever since November of 2010. I guess I'm in my 5th overtime right now. But what I've learned is that we're all in overtime. And of course, this is a community that I don't have to tell that to. You guys know that so well, and you can hear the clock ticking, whether it's for your loved one or for yourself. But I think that sometimes people outside of this room can lose track of the fact that we really do need to make the most of every second. The next is to question the status quo. If we hadn't questioned the way that Castleman disease was thought, the way that it was treated repeatedly with chemotherapy, and really come up with a new approach, I most certainly would not be alive today. I most certainly would not be standing here in front of you all. The third is for the gentleman in the room. I hope that you're never confused as your dad's pregnant wife. But if you are, I hope you can find some humor in that and life's challenges. And for the women, I hope you're also not confused as your dad's pregnant wife. But in life, there are a lot of challenges, and you all are perfect examples of this. There's people like Kyle in this room who find humor and happiness in the midst of so many tough challenges, and so continue to do that. Continue to find positivity in the midst of the storm. The next is that solutions really may be hiding in plain sight. This drug that I'm on that was developed for kidney transplantation, saving my life, I think is a perfect example. And then the last is that it really takes an army. If it was me working on my own by myself, we would have probably made 1/1000th of the progress that we've been able to make. But because I've had this incredible army of people fighting along my side, fighting with me, encouraging me, supporting, and being a part of this fight, we've been able to make the progress that we have made. And so my last request and my main request to you guys is let's all be part of this army together. Let's continue to support one another. Let's continue to be there for one another. A victory for one of our diseases is a victory for all of our diseases. And so I hope you guys will all be a part of our army, one unified rare disease army. And as part of that, I want to close by doing what we call a Castleman warrior flex. And so we talk about the Castleman, and we do this warrior flex. And I think this would be the largest warrior flex of all time. If we can get everyone up and to do this Castleman warrior flex. But it's not just a flex, it's in your face too. It's like, So let's see if we can get the largest warrior flex of all time. Oh, we got it, the camera here, all right. So again, it's in your face too. It's not just the flex, but it's like, and we have to hold it, I guess, for a second. We need to get the whole room too. Nice, thank you guys, thank you. Yeah, so I think, do we have a few minutes for questions still?
Q&A, yeah.
Cool. Great. So we've got a few minutes for questions and answers.
First, a huge round of applause. Thank you.
Thank you. Oh, thank you. Thank you. Thank you. Thank you. Wow. Thank you, guys. Thank you. Wow, that's so sweet. Thank you. Thank you. Thank you. Thank you so much. That's
Thank you.
So sweet of
Okay,
you.
Pam, I'm going to start over here.
Hi, thank you so much for your presentation. That was really inspiring. I'm curious about, do you get regular infusions? How did you decide on your treatment plan? And like, what does that look like?
Yeah, it was really challenging early on because no one had used this drug for my disease yet, but we relied on what had been used in other diseases. And I think that kind of gets this whole idea that, we're all in this together. We're all part of one army. And so we looked at another rare disease called autoimmune lymphoproliferative syndrome, and we looked at the dosing that was used in ALPS, the frequency in ALPS, and then we just borrowed it for Castleman disease. Great question.
Thanks, Pam.
Hi, David. I'm Kevin Fryer from Salem Oaks. Thank you for talking to me earlier.
Yes.
But also, you talk about this army. Where'd you find them? Were they just waiting around for you to come and be their general? What was the first step?
Yeah, how did we build an army? So I talk about this a bit in my book, that early on I was reluctant to share with other people that I had Castleman disease, and that I kept it very close to my chest. I think that I don't know exactly why I did that, but I just had a hard time being open. But when I had my fifth flare and I almost died for the fifth time, I turned to my classmates and started just kind of being open. Like, I have this deadly disease, I'm trying to cure it. And they were so amazing, just wanted to get involved. And so I think that, I was fortunate. I was in graduate school at Penn, so there were a bunch of other graduate students who wanted to be a part of solving a disease. And so many of those people have stayed a part of the Castleman's army since then. There's also a lot of loved ones of Castleman's patients that they maybe wouldn't have gotten involved in research if we hadn't been so clear that, like, we needed them. Within Castleman disease, we really have this feeling that, if we don't do it, no one is going to do it. And I think that we should all feel that way, because the people in this room are doing the work that needs to be done. But if we didn't do it, then no one would. And so I think it's communicating within our patient and loved one community that, like, we have this amazing opportunity, but it's not going to happen if we don't do it.
Frida?
Hi, Megan Golden from Mission Cure. Thank you so much. I'm wondering, why wouldn't the clinicians give some of the patients now the sirolimus before the really harmful chemo, and what would it take to get to that point?
It's a great question. So wondering, what's kind of stopping doctors from using this drug off-label before patients get too sick. And so some doctors are using sirolimus off-label early stage, but it does get to this really important question in medicine that you do need to do clinical trials. When drugs are used off-label, it's still important to do those trials so you can study in a really rigorous fashion. Does the drug work? Who does it work for? Who does it not work for? That's really hard to do if you purely do off-label drug use. And so some doctors are doing it, but some doctors that maybe are a little bit more traditional, and I don't think it's the wrong thing, are waiting for there to be more data. And so we want to do both. We want to support people who want to use it off-label. We also want to generate the data to support people who need more information.
There actually is a question over here.
Oh, sure.
Hi, my name is Roberta from the Allergy Syndrome Alliance.
Hi.
In February of, not this year, last year, our entire board went to a research lab for a scientist that was working on Alagille in kidneys. It was an unbelievable experience for our board. We gave biosamples, understood the isolation scientists go through, and also the difficulty that they have sometimes to correlate tiny little things like
Yes.
whether your urine is concentrated. These are questions that they can't answer. It really changed the scope of our organization. It really has driven us to go into research in a way that we had never done before. Our organization's 26 years old, so we like to say 26-year-old, 1-year-old. Something that we have really been inspired by was giving those biosamples, and the lab has taken those and done just tremendous things in the mouse model. So in trying to understand how, as an organization, can we create a biobank for ourselves? Do we build on a biobank that's current in a children's network? Do we try to find a place to do our own? And now, we're in a proposal period for writing our own research collaborative network as part of, this biobank would be part of that. What is your experience with a biobank? Recommendations on build on what we have, proposals for a network, or find our own?
It's a great question. So when we were early stages with the CDCN, we wanted to outsource our biobank to a company that could actually collect the samples for us, store the samples. We felt like that was one way for it to be not connected with any one institution. We thought that that would be a positive because we didn't want, researchers were often competitive with one another. I don't think it's the right thing, but it happens. And so I didn't want it to be at any one institution. But unfortunately, what I found is that there's so much work that goes into consenting patients, especially if you're doing telephone or electronic consents. There's so much work that goes into all the coordination that this CRO, and of course this is only one that we worked with, really was not capable of kind of doing the extra work needed. I mean, we sometimes consent people at 11 p.m. at night on weekends. And so things like that the CRO just wasn't able to do, and samples, when patients are in the hospital, we need those samples so we can learn about this disease. And so we ended up actually discontinuing our agreement with that biobank, and then ended up setting up a biobank at Penn where we share samples, and to make sure that other institutions were okay with it, we give the samples back to the other institutions for research if and when they request it. So we ended up deciding to go with one institution, and I think every field might be different, but it's so important to have a great biobank and make sure that wherever the biobank is, that those samples will not sit at that one institution. I talk about this a lot in my book, but the thing that broke my heart the most when I first started doing Castleman's research was learning that there were samples that were sitting in freezers for decades at a time, and no one was touching them. And you've got a disease where no one knows what's going on, and then you've got samples sitting in freezers for decades, and those patients died battling their disease, and their samples aren't being used. And that's something that I think is, it shouldn't happen, but we as a community need to figure out ways that we can get those samples out of freezers and make sure that we figure out insights about these diseases.
Pam?
Troy Townsend, Cure Blount Syndrome Foundation. I love the idea of the collaborative research network, and it's something we're trying to put together. Is there a technical platform where doctors and patients can keep in touch that you found is effective?
We did used to use a platform called GHD Online, and GHD Online was not developed for rare disease communications. It actually stands for Global Health Delivery, and we were basically repurposing their platform for this sort of communication between physicians and researchers. We used another website called Code Digital for physicians and researchers to prioritize and contribute ideas for research. We also just used simple Google surveys in the early days to get ideas for research. We're partnering with Chan Zuckerberg Initiative to try to figure out better tools than like repurposing a global health page and repurposing a general crowdsourcing page. And so hopefully by early next year, we'll have some tools that are maybe ready to be shared and approaches that other people can use.
Frida?
Hi, my name is Robin Powers. I'm from Buffalo State College. I just wanted to say first, thank you for the way that you delivered your speech and the way that you left it very inspirational. Although I can see that it was an extremely difficult journey, I've kind of had a very difficult journey myself, and it's very refreshing to see the way that you delivered it, using still positivity and inspiration and hope throughout the entire thing.
Thank you.
And then you're welcome. And then I was also curious. I can see that you're trying to work, all as one, which is actually my own perspective. So if I was curious, if there's a way I could work with you or something, if there's a way we could connect or something.
Absolutely. I love bringing on new people in the Army. Absolutely.
I would love to be.
Yeah, we would love to bring you on. And I know that many of you guys and your organizations are the same thing, but anyone who wants to get involved in the CDCN, there is a job for that person. There's something that is a perfect fit for them because we're trying to do a lot of things, whether it's conducting research, analyzing data, engaging with patients, raising money, raising awareness. And so I hope you guys all do the same thing as me, which is that if anyone wants to join your Army, bring them on, get them on board. I hope many of you all will be a part of our collective army. But yeah, absolutely, would love that.
Thanks. Pam?
Yeah. Hey,
Hi,
Rob.
David. I think you know me, but there's one thing that I did want to share that I think the first time that we met, and I don't know that I've ever told you this, but it has forever resonated with me, and it is the reason that I am where I am today. And I think when we had that first conversation and we met, and you explained to me your journey and how you had done this unbelievable thing that I think everybody in this room sits there and goes, how on earth am I going to cure my own disease? And I sat there and I said, Dave, do I need to go back to medical school? I said, I think it's going to take me a long time to get this all figured out, but I'm willing to do whatever it takes. And there's one piece of advice that you gave me that has stuck with me forever, and it was that in this broad ecosystem of the rare disease community, and even within each disease state, that everybody has such a vital role to play, and that not everybody is going to be positioned to cure their own disease or to go out and raise $1 million for their own disease, but everybody has a role.
Yes.
And you need to find out what that role is, what you're good at, and then use that role to make the most of that. And I've been incredibly fortunate to kind of find what my role is, to be able to support incredible people like yourself. And so I kind of wanted to share some, more of a comment than a question to everybody else in this room that you sit there and go, I don't have a medical degree from an Ivy League school. Like, what could I possibly do? Is, my advice to you guys is to find what you can do, find what you're good at, and just do it to the best of your abilities. And people will recognize that, and it will support and hopefully have a very positive impact down the road. So, thank you.
Thank you. And Rob really listened to that advice because you've had a huge impact, and it makes me feel great to know that I've had a small part in that.
David, we have a couple questions that have been submitted online.
Sure.
So one of them is, how do you tackle patent-protected compounds to see if there's a shelved drug that could help?
Yeah, that's more challenging. You need to work with that company. So if you find a particular pathway or something that you think could be helpful for your disease, and you use a website like OpenTarget, and you learn that there are drugs that have not yet been FDA approved that are under patent protection with a particular company, then you need to get in touch with that company and see if they'd be interested in collaborating with you. And many times, if the drug's truly on a shelf and not being used, I can promise you the company will want to at least have a discussion with you. And if they don't have a discussion with you, come talk to me, because I want to help you to try to get them to have a discussion with you. And I really think they will. So start having discussions. It doesn't mean that they're necessarily going to provide the drug to you, but share with them about what this means and that it could be a potential way forward for them.
Okay, one more question. Rare disease patients struggle with early diagnosis and incorrect diagnosis. As a doctor who was diagnosed with a rare disease, what advice would you give to advocacy groups to help get their disease known by doctors and medical students?
Yeah, it's really tough. So 7,000 rare diseases. There are not even 7,000 days in medical school, right? You've got 1,200 days. You got 4 years to train a medical student. And much of that time treating patients in the hospital. So you don't have the time to give the time that's needed to each one of these rare diseases. So I don't know what the solution is from our end, from the foundation end, but I think that what we can do is, among the physicians and researchers that are out there, it's getting them together to get a unified front on what's known and what's not known. Unfortunately, for a lot of rare diseases, like, some experts know a lot and other people don't know very much. And if you can really get everyone together to get on the same page, then that way when that new medical student is coming up, they can, and they're going through training, they can quickly and easily get an idea for what's the lay of the land, so they can, insert themselves pretty quickly.
Thank you, David. So you really are true inspiration. We so appreciate you sharing your story and supporting the rare disease community. I also want to announce that the partners at Chan Zuckerberg Initiative have graciously purchased copies of David's book for all of our attendees. So, since hearing this, I've been waiting for my big Oprah moment. Ready? So you get a book, and you get a book.
You get a book?
Everybody gets a book.
Yay.
Thank you so much to CZI for that donation.
Yes.
You will be able to pick those books up in the exhibit pavilion following this session. David will be signing copies. We're going to give him a couple of moments to get over there. And so do stop by. Molly's going to take him to the exhibit pavilion. And I have just a couple more housekeeping notes, and then we'll let you all go over there and get them as well. Thank you, David.